In verilog, there will be a three coding styles. Okay, they are first one is structural model, second one is data flow model, and third one is behavioral model. Okay, today we are going to discuss behavioral model with one example. Okay, I mean, sorry, we are going to discuss the structural model with some examples. Okay, I think everyone have a good idea regarding the full adder, right? See, this is how the full adder looks like, right? Full adder logical diagram. In this, how many inputs are there in full adder? Three inputs, nothing but A, B, C. What are the outputs? Sum and C out. Okay. By using this diagram, today we will write a code for full adder. Okay. See, first I am creating a file name I am given as full adder. We are writing in a verilog, so I kept this in a verilog. Later, module is a keyboard. After that, we can give the name for our code. I am giving here as a full adder. Now we have to be declared inputs for A, B, and C. You can see in this diagram there are three inputs, right? A, B, and C. Right. Now what are the outputs? Sum and C out. So for that reason, now I am taking the outputs. Okay. Output, sum, and C out. Okay. Today we are going to discuss. We are discussing the structural model, right? So which gate is this? XOR, right? So for that reason, inbuilt there is some keywords in tool. We can use the keywords directly. That is XOR gate, right? XOR. See here. Here it's getting some output, right? See, first we are doing for this gate. Consider here the output of this XOR gate will be W1. Okay. Now output is first we have to be declare output W1, comma. What are the inputs? A, comma, B. Okay. This W1 we are yet not declared, right? So for that reason, I am declaring the W1 first, which W1. Okay. Now, according to the diagram, up to here is done. Now, what we have to be take? This one we have to be considered, right? Now, to calculate this sum, we have to be considered this. Now, here, what are the inputs? Here you can see W1 as an input and C is seen as an input for this XOR gate. Output is sum, right? So for that reason, that is XOR gate, right? So XOR, what is the output? Here sum. What are the inputs? W1 and Cn. Okay. Now up to here, coding part is completed, right? Now we will see. Now we will implement this one. Okay. This is which gate? It is AND gate, right? So what are the inputs for this AND gate? One is here you can see W1 input and Cin input, right? Here consider output of this AND gate is W2. Now AND gate, right? It is. And what is output there? W2. What are the inputs? W1 and here you can see W1 Cin. Cin. Later, what we have to do here for this AND gate, what are the inputs? A and B, right? Consider the output of this gate is W3. Okay, W2 which W3. What are the outputs for that AND gate W3 and what are the inputs A and B, right? After this, now up to here completed. Now which gate is this? It is OR gate, right? For this output is C out. What are the inputs? W2 and W3, right? So OR C out W2 W3. Now our coding part is completed and module. Okay, just save this code and we have to compile, right? Compile. There is some errors. Let's check what are the errors. 8th line, 10th line, 11th line has got some errors. Now again we are save. Again we are compiled. Now code is successfully compiled. Now we are writing a test bench for this program. Okay. For that again we are creating one more file and we are giving a name as full header test bench. Okay. This code also we are writing in verilog. So we are giving a name as verilog. Okay. And we are opening that file module and full header. You can simply give us TB. Now what are the inputs? A, sorry, A, B, and C. What are the outputs? Sum and C outright for full header. Now what we have to be do? We have to be do instantiation. Take this design module name, paste it over here. Just give a name. I am giving here A1. You can give whatever you want. Now, what are the variables inside our design? Nothing but full header. That variables we are giving connection with our TP. Okay. So dot A is connected to in TB A, comma B, and Cn is connected to Cn. Dot sum is connected to sum. Dot Cout is connected to Cout. Okay. Now what we have to do? We have to be do we have to review all the combinations, right? So for that reason, we put a initial. Why? Because it will execute in a 0 seconds. Here we are going with multiple statements, right? I mean, we are doing with multiple statements. I mean, there are 8 combinations, right? To execute that eight statements, we are using a begin statement here. Okay. What are the combinations are there? A equals to 1 tick. The size of A is 0, right? So B equals to 1 tick B 0 and C equals to 1 tick B 0, right? After giving 10 seconds here, now again checking one more combination. 1 tick B1. Yes. 1 tick B1. B equals to 1 tick B0 and Cn equals to 1 tick B0. See, what I'm doing here is, uh, just give me 1 second. Then here you can see the truth table, right? Just give me 1 second. See, in this truth table, I'm giving the all possible inputs. Okay, this where we have checked. I mean, in this first row we have checked. Now we are planning to check the second row, right? For that second row, we have to be give Cin as a 1 and remaining 2 as zeros. Okay, now come back to output 1. Later, which combination we have to be checked by seeing this truth table. Now B is 1, remaining two inputs are 0. Okay. B is 1, remaining two inputs are 0. Okay. Now we will see with one more combination. B and C are 1, A is 0. B are C are 1, remaining A is 0. Now we will see one more combination. Here A is 1, remaining 2 are 0. A is 1, remaining 2 are 0. Now in this combination, A and C are 1, B is 0, right? Now on next combination, what is here C is 0 and A and B are 1 and next combination all are 1s, right? A and B1, C is 0 and in last combination all are 1s, right? So I am making all as 1s. Now our test bench is completed. Uh, and module. Okay, just simply save it. Just compile the code. See, there are some errors. We need to fix it before going to the what are the errors? Net reference. Okay. Here, while writing the test bench, no need to uh, no need to declare the inputs and outputs. What are the inputs? We have to be take it as a rich. What are the inputs here? A, B, and C. What are the outputs? We have to be declare it as a Y. What are the outputs now? Sum and C out, right? Save it. Sorry, save it. Just compile the code. Now all the errors here. There is no errors. Code is successfully compiled. Okay. Now we will check. Now we will simulate this code using what is the module name? Just copy that module name and paste in this terminal. Okay, and just press enter. See here, here it will appear like this. Just right click on it, add to wave all the regions. Now all the inputs and outputs will added in the waveform. Okay. Now just go to the terminal back and just press run. Okay. Then all the what are the combinations we are given in the test bench, that all combinations will be printed here. Now we will verify. Okay. Now we will open this truth table. Here you can see whatever we given A is 0, B is 0, C is 0. At what are the outputs? Sum is 0 and carry is 0. We will verify this whether it's getting or not. Just go to the waveform bar. Just press in first block. Here you can see we are given A is 0, B is 0, C is 0. And we get output as sum is 0, carry is 0. It means the first one is right. Now we will check another one. Okay. Now what is the second combination? A is 0, B is 0, C in is 1. At that time, sum is 1, C out is 0. You can see the truth table for FA. Wait, I will show it to you. Here you can see A is 0, B is 0, C in is 1. At that time, sum is 1, carry is 0. That's what uh, it appears, right? Just give me 1 second. I can see here. A is 0, B is 0, C in is 1. At that time, sum is 1 and carry is 0. And now we can see in third column, A is 0, B is 1, and C is 0. At that time, sum is 1, carry is 0, right? See here, A is 0. Here you can see A is 0, B is 1, and C in is 0. Sum is 1, carry is 1. I mean, carry is 0. It means this one is also vector. We have to verify like this. In fourth combination, here you can see A is 0, B is 1, C in is 1. Sum at that time, sum is 0, carry is 1. You can see the truth table for it. This one. A is 0, B is 1, and C is 1. At that time, carry is 1, sum is 0. Like that, we have to be verified. You can see the all combinations. Next combination you can see here. A is 1 and B is C is 0. At that time, sum is 1 and carry is 0. Now comes to the next combination. On the next combination, A and C are 1s, B is 0. At that time, carry is 1 and sum is 0. And now for next combination, A, B is 1, C is 0. At that time, carry is 1 and sum is 0. Right. Here you can see if all are 1s, sum is 1, uh, carry is 1. Okay. Carry is nothing but here C out. Okay.